Hello everyone. The last time we decided that we'll use XState for our chatbot application, and since that's the first time I'm gonna use that, we'll learn together and we'll see how can it be implemented with the chatbot, and is it a good choice for a chatbot, interactive chatbot, something like, let me show you. It's called Landbot. For something like that, as you can see, this website is called Landbot, and it has a flow which is pretty similar to what XState offers, this library. And we'll try to first use XState without implementing it to our project and see how it works, and then we'll try to use it in our project, of course, if it fits and if it satisfies our needs. So let's get started. We already have our project initialized, but we want to try using it with on a new project, so it's just a pure use of XState, trying and seeing the way it works. So let's install a new project using Wit, and if we go there, there is a quick way we can install Wit. So I think it's here. No, getting started. I think we want to use Wit React template, so scaffolding your first Wit project. Okay, I think we can just run this code and it will ask what template do we want to use, right? So we go back to our projects folder, we do this, npm create with latest. Okay, we want to name it XState test, and we will use React TypeScript, and that has been initialized. Let me open that WebStorm. Where is WebStorm projects? And we have that. Okay. That's really interesting. Has it installed it inside of this folder? Create with XState test, select frame, why okay, framework React, XState test. I think it just didn't update this, so we'll copy that path we want to open and we'll put it this here. Okay, now it appeared. It's funny how Windows work. Trust project, this window. And now we just want to install dependencies, npm install, and then okay, and then we want to start the project. It hasn't, okay, it's been installed, and we want to run dev, and we'll have our XState test project up and running. Let me open that. Okay, now we want to remove all unnecessary code here, and we'll try to initialize XState, right? Let's go to their website. Let's go to the okay, we also have initializer. That's really interesting how it works. Oh, our new stately visual editor is out now. That's so nice. This legacy visualizer is deprecated. It's no longer main. So this is legacy, really? Let's go to their stately. Okay, so interesting. I'm seeing that for the first time, so yeah. Okay, connect GitHub repo, create project. Let's go. Okay, so XState test. Let's see how this works. Project visibility, we don't care about that. How would you like to start? Generate with AI. So nice. Okay, let's see. Started templates. This project is shared with the stately community. Okay, we don't care. And what do we have? Okay, we'd have initial state. Quite similar to the landbot, which we are trying to replicate, right? Especially their conversation flow. So, okay, let me move my camera a bit, because okay, so this one, right? This is the flow for our chatbot, and looks like XState. It's a good choice, and let's see how it actually works. What this gives us. So initial state, invoke action, exit action. Okay. Sorry, I need to move the light a little bit. Okay. Double click any empty area on the canvas to create a new state. Okay. Select a state and click on drag the anchors to create a new transition. Select a state and click or drag the anchors. Okay, double click a state or transition. Let's try the first one. So double click an empty area on the canvas to create a new state. So double click, we have a new state, right? It's not connected anywhere, so it just has exclamation, yellow exclamation mark. Then select a state and click or drag the anchors to create a new transition. So we select, click or drag the anchors. I think like this, right? I mean, we can drag and drop, right? To some other state. So okay. And if we drag to an empty area, it will create another state. And if we choose initial state and then we will drag to new state 1, it will have this kind of transition. That's interesting. And we have event there. Okay, so we have, right, got it. So between each state there is a it's called transition, right? And this transition has, what is that? Okay, we cannot roll back. Doesn't matter. Double click a state or transition name to edit it. So this is transition, this is state. We can why don't we cannot do this. Let me refresh the page. Yeah, we can rename it. Oh, there is, it's called guard, right? Remove guard, and now it doesn't have this. So interesting. Double click a state or transition to name. Okay, we did that. On a selected state, click invoke to add an invoked actor. Okay, I'm still not sure what is the actor. On a selected state or transition, click action to add new actions. I think the best way to understand that is to go to XState and read what are those terms mean to clearly understand, because without that we will not be able to understand. So state, so there is core concepts, as you can see on their documentation, and it explains what is the state machines, actor model, and XState in general. So what it says is that state machines help us model how a process goes from state to state when an event occurs. State machines are useful in software development because they help us capture all the states, events, and transitions between them. Using state machines make it easier to find impossible states and spot undesirable transitions. Okay, state machines model your application logic. Below is the logic for a video player. When the video is played, it is opened into full screen mode. When the video is stopped, it closes out of full screen mode. When the video player is in a full screen mode, it can be playing or paused. And let's see how it looks. Okay. What if we click simulate, right? Play. Okay. If it's opened, it's an open state, right? So it's a state. There is a children's states in that. Okay, initially it invokes an action, I think. Start video. And when it's playing, inside of that state, the next state is post, and after post there is a play state. So we cannot go switch from post to post. We only can do this state, right? And also when the state is opened, we will be able to go to this state stopped, wait 5 seconds, and then the pop-up will be closed. So interesting, so clear to define the logic using those state machines. Okay. It's even better here. Play, okay. Opened playing, stop. Okay, let's go to the next description. Benefits of state machines. Simple to understand, simple to test. State machines are deterministic, which means that they're simple to test. You can test all the possible states and transitions between them. Simple to implement. Simple to maintain. Provide a clear and concise way to model complex user interfaces. State machines can help reduce complexity and improve maintainability by providing structured way to manage state transitions and handle events. Prevent bugs. Highly maintainable. In the backend. Okay, what is a state chart? State charts extend traditional finite state machines to model more complex logic. State charts are visual extension to state machines that use boxes and arrows, much like flowcharts and sequence diagrams. State charts add extra features not available in ordinary state machines, including hierarchy, concurrency, and communication. When you make a state machine in Stately Studio, it's also a state chart. Okay, in Stately Studio we refer to both state machines and state charts as a state machines. Okay, that's interesting. A state describes the machine's status or mode, which could be as simple as asleep and awake. A state machine can only be in one state at a time. So basically the dog is a state, right? Has two states, yeah. Only states there is no transition, which means the awake state cannot be reached. The dog state, yeah. And then a dog is always asleep or awake. The dog cannot be asleep and awake at the same time, and it's impossible for the dog to be neither asleep nor awake. There are only these two states, a precisely limited finite numbers of states. When a state machine starts, it enters the initial state first. Yep. A machine can only have one top level initial state. If there were multiple initial states, the machine wouldn't know where to start. In this state chart describing the process of walking the dog, the initial state would be waiting to walk. Okay, so that's how it looks in the code. States are defined in XState state machines inside the states property, right? So create machine, and then it has initial state, which is asleep, right? It has ID, and it has all the states as children objects. Transitions and events. How the dog goes between asleep and awake is through transitions. Events cause transitions. When an event happens, the machine transitions to the next state. The dog goes between asleep and awake through the wake up and fall asleep events. Transitions are deterministic. Each combination of state and event always point to the same next state. Combinations of state and event always points to the same next state. Dogs never wake up to become asleep or fall asleep to become awake. Right. So wake up and fall asleep, it's events, right? So the dog has woken up, which means that he's gonna be awake. When he falls asleep, he's gonna be asleep. Let's see how those events are described in the code. But let's see what this says. With its two finite states and transitions, this tiny dog process is a finite state machine. State machines is used to describe the behavior of something. The machines describes the things, states, and the transitions between those states. It's a finite state machine because it has a finite number of states. Finite number of states. Events and transitions in XState. So that's how we handle how the events are described in a state, right? So the asleep state can only be triggered by wakes up event. When this event happens, this state is getting transferred, how to say that, to awake state, right? Okay. In Stateless Studio, the arrows are transitions and the rounded rectangles on the arrows lines are events. Okay, so this, as you can see, this is events and these are states. Pretty clear, I think. Final state. Most processes with states will have a final state. The last state when the process is finished. Yeah, that's the final state. The final state is represented by a double border on the state's rounded rectangle box. Do we have that somewhere? Not here, but I think, yeah, like this, right? Can we try to simulate that? Dog is in a waiting state, then we leave home event. Once this event happened, it means that the dog is on a walk. When it arrives home, the state is in a walk complete, and that's the finished state, how it's called, final state. There is also parent states. A parent state is a state that contains more states, also known as a child states. Okay, I think that this the parent states, will talk about them in the next video. For now, I'm really happy that we considered what are the states, what are the events, and if to conclude events triggers states to change. And yeah, and that's how it's implemented in the code. And let's see how the parent states are created in the next video. Thank you for your attention. I think you learned something with me. Consider that I'm also learning, so let's see what we come up with when we are done with this XState library. And have a good day then. See you on the next video. Bye.